GU at I omega C naught times KC. This can be rewritten, and what do I want? I want the value of KC that makes that equal to 1. 1 value of KC equal. Okay? So for KU, this is going to be equal to 1. So I will have magnitude of GU at I omega C naught times KU would be equal to 1. Everybody clear? The magnitude of a product is the product of the magnitude. We have seen that in complex numbers. I proved it to you, and I wrote it as product in complex numbers. So that is the magnitude of I omega C naught times, because Ku is a scalar, it's real, the magnitude is also the absolute value, times absolute value of Ku must equal to 1. Okay? That means that actually I can find, without any iteration, the absolute value of the ultimate gain by taking 1 over the magnitude GU at I omega C naught if omega C naught is the crossover frequency for GU KC, for GU KU, but I don't know yet KU, so I'm not all the way through. So that indicates that perhaps I can figure a way to factor out KU and work with that. So let's go back on the board and let me give you what it boils down to.
Shit, can I see it?
All I want to understand is that conceivably we could iterate different values of Kc until we found the value that gave us log AR at omega C naught equals 0. Or AR at omega C naught equals 1. Alternatively, GOL is GU KC. KC can be positive or negative, and I'm following now the class notes. I can rewrite that as GU prime times absolute value of KC. I have done that so that the factor thing is something positive. Let me explain. First of all, what is that GU prime? Well,
The change?
GU prime will be the same as GU if KC is positive. And when is KC positive? When has the controller gain, when must it be positive? Open loop stable system. GU 0 positive. I.e., when GU 0 is positive. On the other hand, if GU 0 is negative, KC should be something negative. And then the absolute value of KC is minus KC. So then, GU prime will be minus GU if KC negative, i.e. GU of 0. So we can always factor GOL, instead of writing just GU KC, I'm going to write it GU prime absolute value of KC. Why am I doing that? Because the moment that I do that, I have something very important happening. Phi plot of GOL is the same as phi plot of GU. Why is that? Remember, the phi of a product is the sum of the phase of the components of the product. Remember, I showed you before that if I have G equals G1 times G2, the magnitude of G is the product of the magnitudes, but the argument of G is the sum of the arguments. So that means that the argument of GOL at I omega C naught is going to be the sum of the argument of GOL prime, of GU prime at I omega C naught, plus the argument of the absolute value of KC. With me? I got the far? I'm rewriting GOL as GU prime times the absolute value of KC because I need that number to be positive, as we'll see right now. This is a positive real number. What's the argument of a positive real number? There is an argument. Every real number, every positive real number, imaginary part, real part, any complex number, A plus ID, is here. That's the argument. If it's positive real, where is it? It's on this axis, right? Numbers like 3, 7 are on this axis. What's the angle on this axis? 0. The argument of a positive number is 0. So what's the sum? So if I factor GOL as GU prime absolute value of KC, I have the very important fact that the crossover frequency of GOL is the same as the crossover frequency of GU prime. For me, this means, therefore, omega C naught of GU prime is the same as omega C naught of GU. And I know GU prime without knowing KU. With me? So I can find omega C naught without knowing what KU is by doing a body plot of GU prime, no iterations. How are we doing? Okay?
Yeah, I don't really understand why the angle is 0.
You don't understand what?
Why the angle is 0?
Well, any positive number is on this axis, like numbers like 3, 7, 42. They're on this axis. What's the angle on this axis?
Yeah, so does that mean the imaginary is always 0?
Hmm?
Does that mean the imaginary is always 0? It has to be, right?
Yes, but only for positive the angle is 0. If I'm negative, what's the angle?
180.
Minus 180 or plus 180, right? So that's why GU wouldn't work. Because if KC is negative, then the angle would have been minus 180, and that wouldn't be true. Do you understand? That's why I'm rewriting the GU KC as GU prime KC. And a word of caution, as I mentioned to you before, for some strange reason, the chemical engineering control books have been written automatically assuming that G of 0 is positive, and therefore Kc is positive, and they do everything with Gu, which is wrong half the time. Because if Gu of 0 is negative, then that is minus 180, so they are not the same.
Maybe you need to write a book on those. Yeah.
Yeah, where's your book at?
Yeah, my face. Hopefully sometime I'll do it. At least do good notes. At least that. So there you go. So do I understand? Do you understand that we get this very important fact?
Yep.
So we can find omega C naught without any iterations. How about Ku though? Well, let's go back to what I was doing before, but let's do it more intelligently. I think that's the chart that basically when Kc is equal to Ku, we know that the magnitude of GOL at I omega C naught must equal 1, which means the magnitude, now let me write it as Gu prime at I omega C naught times, okay, times Ku must equal to 1 times absolute value of Ku, that's absolute value of Kc here, equals 1. And the positive number just factors out. Okay? So if I have done a body plot of Gu prime, then final result of this, instead of iterating through different guesses of Kc, and every time the body plot of GOL, which is Gu times Kc, you can do a single body plot of Gu prime. The omega C naught of Gu prime is going to be exactly the same as the omega C naught of GOL, and I can find the absolute value of Ku by 1 over the magnitude of Gu prime at omega C. Clear? So basically, graphically, you now do body of Gu prime, not of GOL. You have the body plot. What I do with the orange one? I lost it. Oh, it's on the floor. Okay, I just kidded. So you have the phi curve. You go to minus 180. This is omega C naught of both Gu prime and of GOL, no matter what Ku is. And you have the log AR plot, which is log of magnitude of Gu prime at I omega. Okay, you can't read that on the computer, right? 10 to that is magnitude of Ku. Absolute value of Ku is 10 to the log. So to summarize, to find Ku, all you have to do is carefully figure out what should be the sign of Kc. That comes first. If Kc is positive, Gu prime is Gu. Dylan, question?
Wouldn't it be 1 over 10 to the log?
Oh, yes. Thank you, Dylan. Yes.
That's 1 over 10 to the log.
Yeah, 1 over, as Dylan correctly pointed out. I hope I still have it here. Yeah, right here. Okay? And what we get from the plot is the log of that, so 1 over 10 to the log of it. Shana, please? Clear? No? The plot gives us, it's a log scale here, right? So we get a log of the magnitude of GOL prime at I over C. Felix,
Shouldn't 10 to the log be just the function inside the log?
say again?
Shouldn't 10 to the raised to the log be just a function inside the log?
What do you mean? This is a number. You read here a number. This log is a number. So 1 over 10 to that number. On this, I will do a numerical example very soon. But let's go over the concept again. Approach 1 would be, I'm guessing different values of Kc, do every time the body plot of GOL, and interpolate, iterate, until I get to have close to 0 for log AR at omega c. And this is one way I can find Ku. Alternatively, I can do a body plot of Gu prime. And omega c naught is found the same way, it's the same as the omega c naught of GOL. And I find the absolute value of Ku by 1 over the amplitude ratio at omega c naught for that. Josh.
I think what Felix was asking, isn't 10 to the log of x just x?
Yeah.
Yes.
Okay, but you leave it in that form. So
Because I'm reading from the graph the log. What I read from the graph numerical here is the log.
you're just going to get
I'm, the plot gives you just a number here, right? You have a number here, or the table of the data from the product. You get a number. You get a log. So given that number, that's how you calculate it. And of course, careful, this is the absolute value. Ku is Kc value, so it should have the same value as Kc. So if Gu of 0 is negative, Ku should be negative. If Gu of 0 is positive, Ku should be positive. So this is the absolute value of Ku, and then you have to figure out which is the correct sum. No iterations for this equation. Okay, so that's how we get Ku. How do we get Pu? Good job. Good. That's it. 2 pi over omega c naught.
Break time.
All right? That's how I get Pu.